Okay, 10.3. Says find the value of x given that C is the center of the circle and the circle has a diameter of 12. Okay. Well, if the diameter is 12, that means each radius is 6. And this is a radius, and this is a radius. Now, since the two sides are the same, this is a 45, 45, 90 triangle. So we just use our quick and simple rules. How do you go from the leg to the hypotenuse? This is the hypotenuse. That would be 6 radical 2, because we're getting bigger. All right? So, what we have here is, this is 6, this is 6. Now, notice, this piece here is also 6, okay, because it's a radius. All of these are radii. Now, if we notice though, very importantly, this radii is marked so, which means we have this side being 3. Alright? So if this is 3, and the hypotenuse is 6, we can just use our old friend Pythagoras and say 3 squared plus x squared equals 6 squared. So we're trying to find this leg right here. So 3 squared is 9, so x squared is equal to 36 minus 9, which is 27. Now we're just going to take the square root of both sides, and we're just going to simplify this radical, which breaks down to 9 and 3, 9 being a perfect square. So x is equal to 3 root 3. Okay. Now, on 3, okay, so number 3 is interesting because it actually would be very easy to prove right off the bat on where we're going in this section. But we don't have that yet. So if we look at this, we know this piece right here is the same as this piece because of the hash marks. If this is a 90-degree angle, this is a 90-degree angle. And by our favorite old reflexive property, that piece is equal to itself. Which means, by side, angle, side, we know this triangle is congruent to this triangle. And by good old CPCTC, we know that this piece is congruent to that piece. So we can just say x plus 8 equals 2x minus 3. Subtract x, add 3, and x is 11. So, now we have a new theorem, which actually would have helped us in that previous problem. We know that in a circle, or two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So since we know this is equal to this, we know this is equal to that. And it goes back and forth. So if we know the chords are equal, we know the if we know the arcs are equal, we know the chords are equal. And why that would have helped us here is, since we know this and this are equal, we would know these are equal, which would have left us with this arc being equal to this arc, and thereby this chord and this chord, which makes the arc, would be equal. So once you know more rules, there's more ways to prove things. 10.7. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc, which is also just like the one we just had. So that example would have followed this very easily. So notice what we have. If EG is the diameter, right here, we have the diameter, and DF is perpendicular to it, then HD, this piece, is equal to HF, that piece. And corresponding to that, this arc is the same as that arc. And then scrolling down, basically this is the converse of that same thing we just did, going the opposite direction. That's what the converse does. So it's saying if one chord of a circle, so now we're starting at the chord, is perpendicular bisector of another chord, then I drew that backwards, I'm sorry. So if SQ perpendicular bisects this segment, the first chord is the diameter. So, sorry, I went backwards. I'm just going to change, go backwards on that one. So, if one chord perpendicular bisects another chord, the first chord is a diameter. So, knowing that, in this diagram, circle P is similar to Q. Okay? Or congruent to Q, sorry. And FG is congruent to JK, which is marked with hash marks. Okay? And JK, okay, the measure of JK is 80. Find FG. Well, being that the arcs are the same, since this chord and this chord are equal, that means this arc and this arc are equal. So the measure of arc, FG, is also 80 degrees. Okay, find HK, which is a segment, okay, and the measure of HK, the arc. Okay, so let's look at this. We have a diameter right here. We have a chord coming through at 90 degrees. That means this and this part of the chord are equal. Okay? So since this piece over here is 7, that means HN is also 7, which means HK, the segment, the chord, is equal to 14. Now, since the chords are equal, this arc is equal to this arc. So we can say 11x equals 70 plus x. Subtract x, we get 10x equals 70. Divide by that, we get x equals 7. Poorly written 7. Now, that is just what x is. So if we plug x in, 7 in here or here, we find out that the measure of arc, HK, is 77 degrees. All right, 3 bushes are arranged in a garden as shown. Where should you place a sprinkler so there's the same distance from each bush? Hold on, some of you are probably yelling at me right now because I just realized after I moved on that HK, I always tell you to pay attention to the details, HK is actually this whole arc. So we found out 77 times 2, which is 154 degrees. So sorry about that. Was not paying attention. So I do the same thing you guys do sometimes, just try to be careful. Okay, actually, we have decided midstream that we're going to punt. So this problem is a nice real-world problem. And basically what it's trying to get to is where would the sprinkler be, like where would you place a sprinkler to hit all 3 of these. But it's a pretty abstract, convoluted one, so we are not going to do this. Okay, 10.9, Equidistant chords theorem. So, in the same circle, or 2 congruent circles, next to each other, 2 chords are congruent if and only if they are equidistant, which means basically equal distance, the same distance from the center. Okay? So, you have a circle here, And what it's saying is AB, this right here, is congruent to this if and only if this piece equals that piece. And notice, at a right angle. Okay? So, in the diagram, QR is equal to 16. Okay? So this right here is 16. CU is equal to 2x. CV, which is right here, is 5x minus 9. Find the radius of C. Okay? So, we know, first off, since these are at right angles, that this and this are equal. Okay? So we're going to say 2x equals 5x minus 9. Subtract 3x, divide by negative 3, and negative 9 divided by negative 3 is positive 3. So x is 3. So, if we plug 3 in, we find that UC is, right here, 6. And so is CV, 5 times 3 minus 9. We're going to deal with this triangle, this line up here. Now notice, we're trying to find the radius. Well, the radius is a connection. Why won't this change? There we go. That's the radius, which is also the hypotenuse of this little triangle here. Now, we know CU is 6. I'm going to recreate this right here poorly. This is 6. What's QU? Well, we know that QR is 16. And since this is a right angle, and this is the diameter, and it's intersecting this chord, this is bisected, which makes this piece here 8. And now we just use our old friend Pythagoras to find out what the hypotenuse is and the radius. So 6 squared plus 8 squared equals C squared. So this is 36 plus 80. 8 times 8 is 64. I cannot do math. So that's 100. And we square root both sides. We find out that C is 10. And that is also the radius. So the radius of the circle is 10. I know that's a lot. If you need to hit stop, rewind it, and watch it through again, it'll make sense as we do it more. But that's it for today.